Good morning or afternoon, everyone, depending on what class you're in. It might be the morning or the afternoon. Today, we are going to be reviewing measurement, which was our third unit. Okay, so this is unit 3. And once again, just like in our other review videos, you may want to have out some paper and a pencil or pens that you can jot down some notes. I will post a PDF of these notes on D2L so you can have access to them, but it's helpful to write some things down as you go as well. Okay, so this is going to cover measurement. Okay, and basically we talked about 3 big things in measurement. The first one was unit conversion. Right? So how do we convert from one unit to another? So for example, if we're talking about length, well, if we have a measurement in feet, what if we want it in meters? How do we convert from one to the other? Right? Or if we're talking about volume and we have something in milliliters and we want to convert it into liters, how do we do that? Okay. Or if we have a temperature that's in Fahrenheit, we want to know what it is in Celsius. How do we do that? Okay, and I'm just going to bring up for a second the formula sheet. Okay, so this is something that you have on D2L. I also gave you guys paper copies of this. These have all of the different conversion factors for various different types of measurement. Okay, so the first one over here is length, right? So we have different systems of measurement, which we also talked about. There's the imperial system, there's the metric system, which is what we use in Canada. And then in the middle of the chart, I've got how do we convert between imperial and SI or metric. SI stands for System International. That's because it came from France. It's also called the metric system. Okay, so we've got that for length. The second table is volume. Whoops. So this is like for imperial, we've got gallon, quarts, pints, cups, all sorts of stuff. And then on the right, we've got SI, that's liters, milliliters. We can also measure stuff in cubic meters or cubic centimeters. And then in the middle, we've got the relationship between those two systems. And then the third one, sorry, I mislabeled this. This shouldn't say volume. It should say mass, how heavy something is. Okay, so on the left, we've got the imperial units, tons, pounds, ounces. On the right, we've got SI. So there's also a metric ton. It's spelled T-O-N-N-E. And then we've got kilograms, grams, and milligrams. And then in the middle, there's the relationship between the two. And then finally, there are the temperature conversions. Okay, so those are all of the conversion factors that we're going to use for that first thing that we're going to talk about. Okay, that's the first thing. The second thing that we're going to talk about is linear measurement problems. Okay, so for example, something like perimeter, right? How do I find the distance around a shape? So where this might come up is if you're fencing something, if you're fencing your backyard, or if you're trying to put baseboard around your room, right? The baseboard is like the trim at the bottom of the room, or maybe it's crown molding around the top of your room to make it look really pretty. Or maybe you're putting like wood trim around your window, okay? You're putting something around a shape. That would be a perimeter problem. Okay, so perimeter. Okay, you might also be looking at something like circumference. Okay, circumference is the distance around a circle. Okay, those are all types of linear measurement problems. We're looking at the length around something. Okay, you may want to find out how much does it cost if we need to buy the material to fence our backyard. Well, firstly, we have to know how much material do we need. That's going to depend on the perimeter. And then how much does it cost per meter or per foot or however it's priced. that's the second thing that we talked about. And then the third thing that we talked about were area problems. Okay, so area is a measurement of flat space, two-dimensional space. And so we may have looked at the area of floor that you need. If you're carpeting your floor, that could be a type of area problem. We also though looked at surface area. And the surface area of a three-dimensional shape is the sum of all of the surfaces that make up the shape. Okay, so if you can imagine like a box, okay, a box has 6 different faces, and if you were to cut out the box and make it lay flat, you would find out what's the area of each of those faces and add them all up. Okay, or actually a nice way of thinking about it, if you just wrapped a bunch of presents for Christmas, then how much wrapping paper would you need to cover the entire box? That's the amount of area that would be the surface area of the box, the amount of wrapping paper that you would need. Okay, and so I'm going to come back to this formula sheet and go to the next page, because the next page has all of the other formulas that we need. Okay, so if, for example, we're looking at a rectangle, you've got in the middle the perimeter of the rectangle, formula for perimeter, and on the right, the formula for area, right? Same thing for circle. So a circle, the distance across the circle through the middle is called the diameter, and then the distance from the middle, which is half the diameter, is called the radius, okay? And then this value pi is approximately 3.14, okay? But I want you to use your pi button on your calculator. Okay, so these are the formulas for circumference, which is the distance around a circle, or area of a circle. And then you've also got, for triangles, there's no real formula for perimeter. You just have to add up the 3 sides. For area, it's base times height divided by 2. Okay, under here, these are the, this is for trig, so we're not really going to use this in this unit. But then at the bottom, I've added in the surface area ones because I didn't have those in there, and I kept getting you guys to write them at the bottom of your formula sheet. So I've just added them in. Okay, so surface area of a rectangular prism, which is a box shape, is this formula over here. And then a cylinder is this guy over here. Okay. So we're going to just try a bunch of examples, and the unit conversion for everything except for temperature uses what we looked at in the first unit, which is proportional reasoning. So for number 1, okay, unit conversion. Let's say I asked you, let's go with 2.3 kilometers equals blank miles. Okay, so I want you to convert 2.3 kilometers into miles. Okay, well, what we have to do is go to our handy formula sheet and go to the next page. And we're going to look at length because that is the unit that we're looking at, right? The measurement that we're taking is length here. And if we look at the relationship between mile and kilometer, okay, we can see that you can either use 1 mile equals 1.609 kilometers or 1 kilometer equals 0.6214 miles. It doesn't really matter. I'm going to use the top one. So 1 mile equals 1.609 kilometers. So I'm going to write that down. 1 mile equals 1.609 kilometers. Okay? And that is going to be one side of my proportional reasoning equation. Okay? The other side is going to be these two guys, where this one is my unknown. But I want to set it up so that my unknown is in the numerator. So I'm going to write X miles over 2.3 kilometers equals, okay? Now what I have to do is put this conversion factor into the other side, but make sure that my units are consistent. So the miles goes in the numerator. 1 mile over 1.609 kilometers. And that's why it's so important when you're doing this that you include the units, because the biggest mistake that people make is that they put things in the wrong place. They put the numerator where the denominator should go, or vice versa. Okay, but if you put the units in, you're less likely to make that error. Okay, now to solve for x, all I need to do is multiply both sides by 2.3 because I'm dividing x by 2.3. Okay, so these cancel, and I'm going to get x equals 1 divided by 1.609 times 2.3. Okay, and if I put that into my calculator, 1 divided by 1.609 equals, and then the answer times 2.3 equals. So that's to one decimal place, 1.4 miles. Okay, so x equals 1.4 miles. Okay, so that would be a length example. Okay, now I could also do, let's say I'm doing imperial to imperial units. So let's say, because with imperial units, you can sometimes work like with remainders. So let's say I have 27 inches equals blank feet blank inches. Okay. Now, typically, think about how you measure your height. You don't say you're 5.2 feet. You say you're 5'3". 5'3" inches. That's what it means. So you're 5 feet and 3 inches. Okay. So when I say convert 27 inches into feet and inches, I want to know how many whole feet you have in there, and then how many inches are left over. Okay. Well, again, we're going to consult our conversion factor. So if you look over here on the left, 1 foot equals 12 inches. Okay, so 1 foot equals 12 inches. Okay, so I'll have that down. And what I'm going to do with this one, when I'm working with remainders, okay, I'm actually going to do a little diagram. I'm going to say, okay, this is 27 inches. Okay, do I have enough to fit in 12 inches? Yep, I do. Okay, so 12 inches maybe there. So that's 12 inches. And that's 1 foot. Okay, do I have enough to fit in another 12 inches? Right? So this is the 12-inch mark. Maybe that's a better way of doing it. Well, 12 plus 12 is 24. So that would take me to here. Right? 12 plus 12 is 24. That's another foot. Okay, this is at 27. Do I have enough to get another foot? No, I don't, because there's only 3 inches left. Okay, so if I think about how many whole feet do I have, I've got 1 plus 1 is 2 whole feet. And then how many inches are left over? 3 inches are left over. Okay, so this would be an example where you're actually working with remainders. Okay, all right, let's maybe try a, let's try a mass question. Okay, let's go with 3,500 pounds equals blank tons. Okay, well, let's go to our formula sheet, and I'm going to go over here to the mass conversions. Okay, now you have to be really careful here, because remember there's 2 kinds of tons. TN is the imperial, and that's not what I had. I had T, which is SI units. Okay, so I need to somehow convert pounds into metric or SI tons. And there's no direct way of doing that. If you look at the relationships between imperial and SI, I can't go directly from one to the other. So what I have to do is I've got to go through something else. Okay, so what can I go through? Well, there's a couple things that I could go through. I could actually go through imperial tons because I could go pounds to tons because I can use this first guy over here to do that. Okay, I could also go pounds to kilograms to tons because I've got the pounds to kilograms here, and then I've got the tons to kilograms to tons here. Okay, so those are a couple of options, and it really doesn't matter which one you use. Maybe I'll use the pounds to tons to TN, and then the tons to tons. Okay, so 1 ton equals 1 TN ton equals 2,000 pounds. So I'm going to write that down. And 1 ton equals, I think it's 1.1. Yeah, no, 1 TN ton equals 0.91 tons. Okay, all right, so this is going to be my first step. This is going to be my second one. All right, let's do it. So I want to know how many TN tons are in 2,000 pounds. Or sorry, in 3,500 pounds. So if I put this guy in the numerator, because that's what I want to know. So X imperial tons over 2,000 pounds equals, well, oh, I'm sorry, not 2,000. This is my X, right? 3,500 pounds. The other side is this conversion factor. So the tons is in the numerator, so this is going to be 1 ton over 2,000 pounds. Okay, now how do I solve for X? Well, I'm dividing by 3,500, so I've got to multiply both sides by 3,500. Then these cancel. So X is going to be 1 divided by 2,000 times 3,500, which is, I don't know, let's see, calculator. 1 divided by 2,000 equals times 3,500. That's 1.75. 1.75 tons. Okay, so step 1 is done. Now the problem becomes 1.75 tons equals blank tons, metric tons. So I'm going to set it up exactly the same way. This is my unknown. So XT tons, metric tons over 1.75 tons equals, and then I need to use this other conversion factor. So the metric tons, just the T goes in the numerator, 0.91 tons over 1 ton. Okay, and to solve for X here, I've got to now multiply by 1.75 because that's what I'm dividing by. Okay, and that disappears. So I've got X equals 0.91 over 1 times 1.75. Okay, so let's see what that is. 0.91 divided by 1 times 1.75. So it's 1.5925, so 1.6 to the nearest tenth. Okay, so that's like a two-parter. So if you can't go directly to the units you want, you've got to go through something else. Okay, one other thing I wanted to talk about was temperature conversion. Because temperature conversion actually does not use proportional division. So let's say I wanted to know convert 38 degrees Celsius to degrees Fahrenheit. Okay. Well, for temperature conversion, you've got these formulas that, these two formulas here that relate either Fahrenheit to Celsius or Celsius to Fahrenheit. So how do you know which one to pick? If you're looking for Fahrenheit, you use the one where F is isolated, which is the top one. And if you're looking for Celsius, you use the one where C is isolated, which is the bottom one. So we, in this case, need to use the top one, which is F equals 9 over 5 C plus 32. So I'm going to copy that down. Okay, and I'm going to plug in what I know. What I know is this is 38. So it's 9 over 5 times 38 plus 32. Okay, and then we can just do this on a calculator. And I have a feeling that this calculator is not the best because it was a free app, but the good scientific calculators, you can just go 9 divided by 5 times 38 plus 32 equals times 38. Yeah, no, this one isn't. Oh no, it is plus 32. There it is, 100.4. Okay, 100.4 degrees Fahrenheit. Okay, so this one actually works too. Whoops. My notes quit. There we are. Equals 100.4 degrees Fahrenheit. Okay, so that's all the first point, which is all of this conversion stuff. Linear measurement problems. Okay, so I'm going to do this as an example. Okay, let's say how much would it cost to fence, a circular backyard with a radius of 3.2 meters if the fencing costs $8.75 per yard, and you can't buy part of a yard. Okay, how much is it going to cost to fence your circular backyard? So what I might start by doing here is drawing it, right? Here's the circular backyard. The radius, that's the distance from the center to the outside, is 3.2 meters. Okay, now fencing goes around the outside, right? What is that called? That's called the circumference. Okay, now if we go to our formula sheet, I'm not going to go back there now because I've been flipping back and forth, but there's two formulas for circumference. It's either pi times diameter or 2 pi r, 2 pi times the radius. Now here we have the radius, so we may as well use the second one, right? If we want to know the distance around, because that's how much fence we need, we better use that one. So circumference equals 2 pi times 3.2, and that, let's go back to our calculator, is 2, where's my pi button on here? Shift pi times 3.2. And that's 20.10, well, I'll just make it 20.11 for now. Meters. That's the circumference. Okay. Now the fencing costs $8.75 per yard. So what we have to do now is convert meters to yards because it's priced by the yard. So 20.11 meters equals blank yards. So this goes back to proportional reasoning and unit conversion, right? So now we will have to consult that formula sheet. And if we go to meters and yards, 1 meter equals 1.094 yards, or you could use the top one. 1 yard equals 0.9144 meters. Maybe I'll use the bottom one. 1 meter equals 1.094 yards. Okay, so here I want to know X yards equals 20.11 meters. So that's going to make up one side of my equation. X yards over 20.11 meters equals, and then the other side is the conversion factor, right? And the units that are in the top have to be in the top, like there's consistency there, right? So 1.094 yards equal over 1 meter. Now, how do I solve? Well, I'm dividing X by 20.11, so I've got to multiply by 20.11. And then I get X equals 1.094 yards. Whoops, I'll take the units out for now. Times 1, or divided by 1 rather, times 20.11. Okay, so I'll put that into my calculator. All right, so 1.094 divided by 1. Oh wait, I've got to clear it first. 1.094 divided by 1 times 20.11 equals, and that works out to be 22 yards. Okay, exactly, basically, because it was 0.0000 whatever. Okay, now, how much is this going to cost? Well, you can't buy part of a yard. So where does this come up? Let's say it was 22.2. I'd actually have to buy 23 yards. I can't buy 22.2. Okay, so you'd have to round up there so you have enough. Okay, but we need exactly 22. So the cost is going to be 22 times 8.75. And that is, I don't know, $192.50. Pretty cheap, actually. Okay, so that would be an example of a linear measurement problem. All right, the last thing that I want to talk about is area. And I'm going to do two types of area problems. The first one is going to be an area problem that involves unit conversion. Okay, so determine the area of the rectangle in square inches. Okay, and let's say this is 2 yards by 5 yards. Okay, well, if we look up the conversion factor, right, because we don't want yards, we want inches. Between yards and inches, where it is, 1 yard equals 36 inches. It's right here. Okay. The trick here is that you've got to convert the side lengths first. You can't use this conversion factor on the area. And the reason is this. If you think of 1 yard by 1 yard, that's 1 yard squared, right? So you might think that if you converted that into inches squared, it should be 36 inches squared, right? because you multiply by 36. But 1 yard is 36 inches. 36 inches. Okay. 36 times 36 is not 36. It's actually, I don't know, I think it's like 1,300 something. Let's see. 36 times 36, 1296. So this is actually 1296 inches squared. Okay, so you've got to convert these first. Okay, so if 1 yard equals 36 inches, 2 yards is going to be 2 times 36. 2 times 36, which is 72. And 5 yards is going to be 5 times 36, which is 180. So what you want to do is this. Whoops. Maybe I'll do it in a different color. So this would be 72 inches and 180 inches. Okay, you've got to do that first. You can't convert the area after, which means the area is length times width, which is 72 times 108, which is, let's see, $7,776 inches squared. Okay, so that's the point that I wanted to make with area and unit conversion. Convert the side lengths first. Don't convert the area. Okay, and then finally, we'll do a surface area problem. I'll switch back to black. So what's the surface area of the cylinder? Okay, so I'm actually going to make this a little tricky. I'm going to make this a cylinder where there's no lid to it. Okay, and let's say that this is 5 centimeters and this is 12 centimeters. Okay, well, if we go to our formula sheet to the next page, here's the formula for a cylinder. So, surface area is 2 pi r squared plus 2 pi r h. So I'm going to copy that down. Okay, now here's the tricky part. This surface area applies to the entire thing, not something where one surface is removed. So what you have to be able to do with these general surface area formulas is kind of know where the surfaces come from. Okay, the 2 pi r squared, well, the area of a circle is pi r squared. So the 2 pi r squareds refer to the two circles, one at the top and one at the bottom. So if I only have one of these, this is going to become equals 1 pi r squared plus 2 pi r h, right? The 2 pi r h, by the way, is the surface of like the tubular part of, so if you imagine like a paper towel roll, the cardboard in the middle that's hollow, this is that part, the 2 pi r h, okay? So this is what this surface area would be, where the lid is removed. Now all we have to do is plug stuff in. So this becomes 1 times pi times 5 squared plus 2 times pi times 5 times 12. Okay, and then we just enter that into our calculator. So 1 times pi times 5 squared plus 2 times pi times 5 times 12 equals 455.5. And that is centimeters squared. because the radius and the height are given to us in centimeters. Okay, so that's kind of a little brief picture of that whole measurement unit. It doesn't, of course, cover everything, but hopefully it'll give you a little bit to go on to start